I want to spend a few minutes to talk about three acronyms that, to be honest, confused me for the longest time in my career. This is something that I will always work with, but I take it for granted that exists. And those acronyms are OLTP, OLAP, OLAP, and the new one, which is called HTAP. These are database kind of jargon words. They are important, don't get me wrong, but I'd like to explain them from the bottom up. Why do they exist? Why did we create online transactional processing and differentiate it between the online analytical processing? Are analytics different from transactional systems? And then what's this new thing that is called HTAP, which is the hybrid transactional and analytical processing. So this will be the topic of this podcast. How about we jump into it? Welcome to the Backend Engineering Show with your host, Hussein Nasser. But today's topic is OLTP, OLAP, and HTAP. And let's start with the concept of processing in a database. You create a database, and then you create your data model. And this is usually, you're going to do a normalized data model. You don't have to, but you can. And part of that, you want to execute queries that ensures that you have these asset properties, this atomicity, consistency, isolation, and durability. And then when you execute these queries, you touch multiple tables. You do DML, which is data manipulation language kind of queries, and you edit those tables, right? And if you edit multiple tables, you want this view to be consistent, right? And you don't want to execute one query to write one table and then the power goes off and all of a sudden you have your database with kind of a inconsistent state where something is written and it's not written on the back end on the other table. So that's bad, essentially. Transactions need to be consistent. And as part of making these queries consistent, you split those tables into multiple tables based on your entity model, right? So you have an order table and a product table and a customer table and so on, and then you join accordingly based on the type of queries, and you start inserting stuff. So you create transactions. The system, this is your production database essentially, right? Where your application hits this database by executing these DML queries, and occasionally is going to also query, but this is your production database. So what's wrong with that? This seems to be, most of the time, this is the kind of queries you execute, right? However, we don't only edit, right, in database, we also read. And the nature of queries that you execute for reads really depends on how they will perform based on your data model. Essentially, if you can, nothing's stopping you from using your current transactional production database to execute a query that sums all the products for the past 10 years and check the price of how this product was doing for the past 10 years, or what is the previous versions of this product, and how did it go through these iterations. You can execute these aggregate queries on the transactional database. When I say transactional, I mean this normalized database as is, right? But first of all, these queries are not cheap, because if you understand what the database is doing to do a count, you will appreciate how the database works first, right? And you appreciate the open source maintainers, the developers, the people who are building this kind of system. It's not easy, right? You harmlessly do a select count on your backend application to return the count of how many Instagram likes, but that scans pretty much the whole table. And if you have billions of rows, how do you count? You have to count one by one. The database is not doing anything different. It has to literally go one by one and count, and you can't count fast enough, right? You can do tricks and execute concurrent views, but that can only get you so far. But that, in general, these kind of aggregate queries, analytical queries, let's call them, are slow, right? Because of the work that we need to do. And it is slow because we, in a transactional system, in a transactional database, and guys, I'm talking about relational databases, right? I know NoSQL and key value store have their value, but I don't have enough expertise to kind of talk about those databases, right? So I'm talking about, at the end of the day, it's I/O and logic and algorithms, right? If you think about it, really depends. And one day I'm gonna expand my knowledge to those so I can speak better to how they work, those NoSQL databases. But we're talking about relational here. And the transactional model usually is what we call a row store. What does that mean? It means that when you store rows on your table, right? And let's say your table has 7 columns, the tuple of those 7 values, think of them, they are adjacent to each other. This is stored nice, tucked in together in one block, right? And the second row comes directly after it. So in a block, which is this is how we read from the disk. We read in blocks, unlike memory. We read byte by byte. It's byte address. The disk is block address. It's so expensive to go to the disk, so we always read by page in case of SSD and by block in case of mechanical drive. Right? You read one block and then you get all this data in that block. So a row store stores this in rows. If you pull one block, you get all this content. You get many rows in that block, right? So, and not only you get rows, you get all the columns for free, essentially, for that row, right? In that block. Okay. So if I want to select only one column and I want to sum that column, it is actually more expensive to do that in a row store database, right? Because I'm gonna get fewer rows, right, in a block because I'm encumbered by all this other columns that I don't really need, but I'm given anyway, right? So that's why there's this other concept of a column store database where we store, and instead of storing a row with all the values, we store the column values column by column, right? So column 1 and all the values in all this table. So you, for free, when you read a block, right, that block will contain, and you know which field you want, that block will contain all the field values for that particular field. So you will get way more efficient in a column store if you want to do aggregate, like a count or a sum or an average in a column store versus a row store, right? So that's, I talked about that in another video. Check it out right here. Hopefully I pointed to the right location. So, however, row store is very performant when we want to write and when we want to do a transactions. Column store, not so much, because of the way we need to traverse and build that hierarchy, right, of columns and blocks, right? So transactions are great for rows, but large expensive queries are great for column store. That is why when we understand how these expensive queries actually work, you really can't have one size fits all, right? You really need to think. And you might say, Hussein, I'm going to add indexes on my tables. I'm just going to add a bunch of indexes. Yeah, I can do this queries. Yeah, I'm doing all these kind of queries. I'm going to add indexes. Fine, right? It's definitely, you will need to add indexes, but indexes will only get you so much in a large data set. The more indexes you have on your transactional database, what will happen is when you insert and update and delete a row in a table, all these indexes need to get updated with the values that you just insert. So you need to touch all the B3s, in case that's the data structure that is used to build these indexes. You need to touch those. You need to update them. And that's not so bad. Don't take my word like this is the end of the world. Oh, I have 7 indexes, then it's the end of the world. My inserts are gonna be slow. Not necessarily. It really depends on the depth of the tree and other semantics as well. But at the end of the day, if you have so many indexes at a certain time, when we hit millions and millions and millions and billions of rows, you're gonna start feeling that your inserts are slowing down because of the overhead of updating those indexes, correct? Right? And another side effect in certain databases as well is what we call write amplification. This might be more important in certain for certain customers than the performance of a single transaction itself, right? You want your transaction to be as fast as possible, but still the side effect of write amplification resulting from excessive need of indexes, right, can be detrimental, can have a huge side effect, right? And it's a snowball effect. You're inserting a single row, but that single row in your application, or your application translate that single statement into many statements. Maybe you're updating multiple tables, and each table is really having so many indexes. So physically, the database has to go and update the pages for these B3 indexes, right, to insert the new values you just inserted. So if you have 10 indexes, it has to update 10 entries in those indexes, right? And potentially, this is a result of the B3 structure, you're gonna rebalance the tree. It's inevitable. The more rows you're gonna have, you're gonna balance the tree eventually. Balancing the tree is an in-place update. You're changing the root, right, page, and as a result, you have to obtain what we call in memory, the C++ lingo's mutexes, I believe, or C mutexes. You have to lock the memory in place so that nobody touches that. You can, because you want to perform in place update to that. And then I believe in SQL Server they call it latches, right? These latches or these mutexes slows concurrent transaction even more, right? So the more indexes you have, you're gonna start feeling these effects, right? And I'm talking about low level stuff here. It's very low level, but again, I'm talking about billions of rows, guys, here. No, if you have thousands of rows, you probably won't feel it. If you don't have concurrent users, and when I say users here, I don't mean actual person. I'm talking about back-end threads executing on TCP connections, actually connections, many connections concurrently executing transaction. Databases, yeah, they love concurrency, they support that, but too much concurrency can screw the database actually, right? Especially with locking, it just slows things down. So we try to make our transactional processing, the production database that the backend faces directly, as efficient and as it does one thing, and as the CQRS mantra, right? Command query separation, segregation, whatever it's called. Try to separate writes from reads, essentially, right? So yeah, let's keep the write aspect of this application, and you can doesn't mean you have to do it, just straight split reads and writes. No, of course that doesn't fly. You have to mix and match. Obviously, you write and read. You can do some reads that are reasonable, but doing too much reads that require the indexes you just added, ask yourself, if you're adding an index, what will it do, this index? Where I'm gonna use it? If you're gonna absolutely need it, then okay, suffer the consequences. I say suffer with tongue in cheek. Really, it's just not really bad, right? It's just 1 and 2 indexes, 3, 4, 5 indexes, not that bad, right? Really depends on what. At the end of the day, you have to measure your workflow. I can't possibly in a podcast explain all possible cases, right? It's just, and I don't know everything at the end of the day, right? You only know what you faced, and I'm talking based on my 20 years of experience dealing with databases and kind of working with these kind of things. So these are the transactional aspects of the database. When we move to the OLAP, we establish that we need online analytical processing, right? We're gonna make another database dedicated for reads, and expensive reads, might I say, for older data, archived data that we barely touched, or maybe I'm running reports, I'm doing batch jobs that are executed and then running for maybe, I don't know, 3 hours queries. Fine, you can do it there. You can execute a 3-hour query on a production database, on the transactional system. That will just kill your concurrency on a production system. Yeah, I mean, queries obtain shared locks, but the concurrency, the management of locks and all that stuff, right? I say that assuming that you obtained a shared lock so that your view is consistent. Some queries do that for, like, I'm going to query this product table, but I don't want anyone to change it. So you obtain a shared lock. If you do that, then that's bad in a production database, right? So you move to an analytical database that does that, right? So OLAP is fit for these kind of queries, counts and sums and averages and expensive CTEs and all this stuff, right? You can do it on an online analytical processing kind of databases, right? And usually the word for it is being called data lakes and data warehousing. It goes like, okay, let's put it in the warehouse and let's just execute those queries against it. Now the first question comes in here. All right, I agree. We have a database for my transaction where I write and write and write and write, and occasionally I'm going to read 1Z, 2Zs. And for my expensive, long-running jobs and queries and reports and stuff, I'm going to execute against that. Hussein, how I have the two databases. What are they going to get out? How do you get a what? What are the writes going? How would the other database gets the writes? Well, that's where Hadoop and all these systems came in to solve these problems. The batch processing, right? Moving, doing ETLs essentially, extract, transform, load processing tools to move these data from the OLTP, the transactional normalized kind of tables, down to the OLTP. And you have to move them on batches, nightly, every 3 hours, every 2 hours. And as a result, next question you might have is saying, I'm going to get stale data. Sure, that's the price we pay. And companies are still struggling solving this problem. Kafka tries to solve this by trying to do this in real-time fashion. And it's really commended what they're trying to do, right? For the longest time, we have this batch process. Run a nightly job, Hadoop or whatever, and move everything that you have here in the transaction, then new changes to the OLAP so I can run my long-running, expensive queries right here, right? And I don't care if this is, nobody's touching this OLAP is except us. So if the query takes 3, 4, 10 seconds, that's fine. That is fine. I can host it even in a cheap what the hell is this? HDD hard disk, like spinning. You can definitely host it there. Queries are slow, fine. But if you have money, you can obviously put in an SSD. And that's fine because SSDs, they love things that don't change, right? In OLAP, you don't change stuff, right? It's just really almost static, right? Well, that might be wrong because what happened if you update? So yeah, I might take that back. But essentially, that's what we used to do, batch. Kafka came to the rescue, and then all this message queuing with Kafka Connect and essentially not guaranteeing, promising the idea of having real-time communication. I'm going to give you real time. As you insert that stinking row and you touch all these tables, immediately we're going to move it to the other view, right? To the other database. So you can build this, right? Because you can push these changes to Kafka, and then there's another process which consumes from Kafka immediately and applies the changes to the OLAP, right? That's how basically it's almost like a message queue. It's a pub subsystem, right? Which uses a queue. But obviously that's why Kafka is very, very important to use, because they have this exactly once guarantee. Because if that fails and you try it again, Kafka should tell you that, hey, by the way, you did this, don't apply it again. That is very, very critical, right? Idempotency, guys. Idempotency is very, very critical in this concept, right? So yeah, Kafka, but obviously, when you tell company, hey, there's this thing, there's OLTP, there's OLAP, and you have to deploy Kafka, go hit yourself in the head, right? They all freak out, right? Just like, wow, I'm managing all these systems and infrastructures just to maintain real time. Sometimes people say, nah, I don't want real time. it's not worth it. It's not worth it to deploy to Kafka. Kafka is a beautiful, beautiful software. I love it. But maintaining it, I don't know. I never maintained it, but boy, haven't you seen Kafka? It's a beautiful design, but it comes with its complexity. Zookeeper alone. They're getting rid of Zookeeper anyway, so that's gonna be easier for maintenance. That's good. So yeah, so that's the tail of data warehousing and OLAP and OLTP and transactional. And that's why I try as much as possible when I design a database. I try to make it OLAP kind of database, and at the same time, so I work very hard on my data model such that it's like, okay, what kind of queries I'm going to execute against? I really think hard, and I don't look at the queries. And if there's a query like from an app that is, I don't know, belong to an admin and they are using a field, I don't add an index on that. Let the admin suffer. Screw the admin. I'm not going to add an index for my admin. The admin can wait. They're patient. They can wait. My customer, on the other hand, that's why, guys, when you add a feature, think really, really long and hard before adding a feature to your product, right? Because any feature you add, I'm gonna search by order ID and by name and by first name and by filter and by my mother's maiden name, and I'm gonna search by my SSN. I'm gonna let people search with everything. You can, but you're gonna shoot yourself in the foot. That's why big companies look at their Instagram. Instagram is not allowing you to search by certain fields. It's just like there's this random search, and they cook the shit out of everything. Right, everything is cached, multi-layer caching to achieve this search, and you don't get real time. That's not real time data. That's definitely not real time data. All the numbers that you get on Instagram or these big apps, they are not the actual numbers. They are delayed, so delayed, right? Because you don't see them live. It's very hard to get live data, right? Well, this is expensive. Once you build a system, you understand how expensive it is. And I'm not talking about, I spun up a database and I built an app hitting that database. No, actually production. Because if you start supporting all these features and you start adding, all these features, and users will start using them. And when they will query against your mother's middle name, that query is going to be slow. And you're going to look at the backend and say, of course it's slow. There's no index. Admin, add an index. Okay, I'm going to add an index. Hey, they're searching on SSN. Admin, add an index. A few months later, you have like 3,300 indexes. I'm exaggerating. But you get the idea. Features, think about it. Yagni, you ain't going to need it. If you're gonna need it, add it. Really think hard about the features you add. All right. Now, that being said, what I'm talking about here is the OLAP versus the OLTP, right? OLTP versus OLAP. And now there's a new thing that's called hybrid, which kind of does what Kafka, the Kafka solution, but it's like baked into the database. MariaDB came up with an HTAP solution. MariaDB is, by the way, if you don't know, it is a fork of MySQL. Once MySQL was acquired by Oracle, the author of MySQL, I believe, they just forked and called it they forked MySQL and called it MariaDB, and they went to town. It's a good database. It's a really good database. So they have a column store data engine, because that's how MySQL works. I love MySQL design, by the way. If I have said it many times in this channel. I know. I'm freaking out. I love MySQL architecture. The idea of separating the data engine from the DBMS is genius, right? And I love Postgres. It's my favorite database, but I wish they did that, Postgres. Right? A lot of people disagree with me, obviously. They say having multiple engines like MyAsm or NoDB or MyRocks or other column store database engine, compatibility, maintainability of the software becomes harder, which is true. Definitely, it's features. At the end of the day, supporting more features, more complexity, more bugs, more money, more problems, right? But I love it. I absolutely love it, because now you can extend it. Hey, let's build a column store database engine, just like that. I'm going to create my table as a column store and just change the database engine. Boom. Same database, two tables, different engines. One is, you can have a database engine as a CSV. The backend is CSV. Oh, obviously that's bad, but it's useful. It's useful. If you want to convert your data to CSV, just change that engine, swizzle the engine to CSV, and poof, all the data is dumped to a CSV. But Postgres has another solution, right? It's a different system. It's a different beast. I know I'm going all over the place, guys. I know. I'm sorry, but talking about MariaDB, we're talking about MariaDB, and they managed to do this HTAP thing mainly because of this extensibility of MySQL, which I love, absolutely love, right? So now they have the hybrid model. They support a transactional, which is the native MySQL MariaDB, right? And they also have a column store, right? Database engine. And what they built is this hybrid mechanism, asynchronously updating the backend OLAP through the OLTP. They just mash it up together. I can't speak in details about it. I believe it's asynchronous, but that's what I think. Right? It could be synchronous, but I really doubt it. Synchronicity kills performance. So I really doubt it's synchronous. It has to be asynchronous. Another one is Oracle actually came up with a solution, an HTAP solution called Rapid. I talked about it right here. Rapid, Oracle Rapid is this MySQL. I don't know if it's MySQL. I forgot actually. The details in the video, but that's another hybrid approach. It's like, okay, hey guys, once you move to us, we're gonna do the OLAP and OLTP. You don't have to worry about everything. This is very enticing for companies. What? Really? You're gonna manage all of this for us? Sign me in. Companies love that. Throw the money. I don't have to maintain Kafka and databases and write those batch jobs. Ugh. ATLs. Ugh. C# ETLs. Oh my, how many ETLs I wrote? Oh my God. I lost count. There are just 3. I lost count. Oh my God. But yeah. All right, so let's wind down and finish the podcast. So we talked about OLTP, online. I don't know why they call it online, but I guess has to be. I think it's just an acronym, right? Transactional processing, which is your production normalized kind of optimized for writes workloads. Right? You want those transactions to execute. You want them to be short, sweet, and fast, because that's what the customer hits. That's what the end user hits. Right? You want them fast. Transaction, you want them fast. Don't execute like thing. Don't add features that you're not supposed to add in a transactional. If you absolutely want to think twice about the data model, think how you can optimize this query so it's fast. Always think about scale, right? Avoid queries that does like 100 joins, right? To produce some sort of content, right? Joins, well, kind of nice, but they kind of can kill performance if you join multiple tables to produce some sort of view. Then once you start doing joins, really think about doing it another way, really. Think is like, is this really necessary? If this is necessary, then yeah. Because joins, the larger the tables get, it scales proportionally with it, right? So that's your OLTP. OLAP, on the other hand, for queries, aggregation, things, reports, 3-hour queries, and things that are kind of ad hoc-y. They do not really execute on the production transactional system. You don't really change the OLAP, barely change it. It's read only most of the time, right? So it's optimized for these kind of workload reads, right? And that's it. The final one is we had these two natures. We have two natures of queries. Queries that read and are expensive by nature, and the queries are writes and need to be fast, right? DML. And kind of queries that are also read but also fast, need to be fast. These are the OLTP, right? And these, the long-running aggregates, count, average, needs to exist somewhere else. You can't put them on there. You can, but you're gonna suffer. You're gonna consume additional resources that these precious production transactional resources, and instead of spent serving actual customers, you're querying and serving that long learning query, right? So we had to separate them. We had to produce the OLAP and the OLTP, and as a result, we created a gap, right? All of a sudden, we have delay in the data. We have eventual consistency. That's a fancy term for you. So to reach that consistency between the two databases, we need to update them, right? And to update them, we invented a whole suite. So people made so much money with these ETL tools, right? Moving data from the production, the transactional to, I keep saying production, that also a production database. The OLAP is a production, right? But it's a different kind of production. It's not the active production, if you will. It's a data warehouse where we, on the back end, we're just doing our own thing. Nobody's watching us, kind of a thing, under the table, trading horses and stuff. But so there is this HTAP, the hybrid approach, which combines both two natively in the database itself, so that it can update that asynchronously. At least the rapid model, I'm pretty sure it's asynchronous. It's just the moment you insert, there's a job that picks up and then writes it. So there is a delay. There's still delay. You're not gonna see immediately you'll write into whatever you wrote in the transactional system. You're not immediately gonna see it in the OLAP system, right? It's gonna take a little bit of a delay. I believe Rapid and HTAP, they give you the option if you want, and it's not really rocket science. They just make it synchronous, right? That insert, that commit, only, that's probably a little bit harsh, but I'm just making stuff up right now, guys. So take it with a grain of salt. That transaction that you just committed, I believe it will commit successfully if that commit also committed successfully on the OLAP, right? And only then it will return to the user, return successful, right? That's the quorum approach, at least with Cassandra, right? Where you write multiple nodes, and if two succeeded, I declare this as a winner, right? So there's a synchronicity, at least, working. And guys, if anyone listening here expert or know more about the HTAP than I do, let me know. Reach out and let's have some more discussions. And if correct anything wrong that I said, I'd love to be corrected. Appreciate you guys. And it's been a long episode, huh? But I had a lot on my mind, so I had to just kind of talk about it organically. I know some of you don't like these kind of long videos, but I enjoy making them because it's very organic, and it's I'm in California, so that was a terrible joke. All right, and I love just talking whatever in my head. I just really I without scripting or anything like that. I had literally started this video with 3 bullet points: OLTP, OLAP, and then HTAP. That's it, right? I don't even have them written here. It's just right there. And I started and I made around what? Are we in an hour already? I think we made an hour video out of it, or an hour podcast. I enjoy this kind of content, free form. You see my thoughts, right? And I talk about many things. I can't possibly make a 60-second video talking about these kind of details, right? We have to kind of explore, and you walk with me through all of this thing. And I call myself out all the time when I miss something out, or when I reach a dead end. So, okay, this doesn't make any sense. And I say that, oh, this doesn't make any sense. I don't know, right? And guys, if you like this content, make sure to check the podcast out, rate it, share it with your friends, like this video, subscribe, all that good stuff. And I'm going to see you on the next one, guys. Stay awesome. Goodbye.